Good. Good. Well, that doesn't look good. See if I can get TC on those same parameters. Yeah, stuff's still good. It's fine.
What?
Yeah, the iteration for both of those, I changed the iterations to
Oh.
70.
I see. What was it before? Like 500?
200, yeah, that's the default, but the default's a little bit off there.
I think it's going to work. I got a feeling.
Okay. I'm concerned about that principal component. Did not look healthy. If this fails, yeah.
No, that looks okay. Well, I mean, it's not wonderful, but you didn't,
Okay, so let's see.
It's a
Large
start.
dots, that'll help.
to start.
Okay. And then we do look at this by sample ID. We should be able to see if there's anything
Right.
really obvious.
We don't want too many cells anyway. Oh.
The other one I could try, did we show, I think we looked at UMAP last time.
Yeah, heat map is good.
No,
Oh, UMAP. Yes, you did that. Yeah.
And very few cells, we might even lower this nearest neighbors. And then these cells. This algorithm is normally really, really fast anyway, and so on a small number of cells, it should be pretty quick.
And while that is running, just a quick question. So, like with Surat, I know like when you have the clusters, and when you do the heat map, it kind of does that like what genes define each cluster compared to the rest of the cells.
Right.
And I know here, if you really want to get a differential gene expression, you have to do it like one population versus the other. Is there like an automatic way to just say, oh, just give me a heat map based on all these clusters and tell me what is different?
Yeah, absolutely. I mean, not necessarily based on the clusters yet. That is something we've thought of. We'd like to get it in there at some point. Currently, though, I would want to do that if you're asking for like the same functionality as Syrah.
Yeah.
Is I open up these plugins and I just run Syrah.
Sure. Okay.
Because that's just an R package. That was like one of the first plugins we developed for CT.
Okay.
Although obviously it doesn't give you as much. It's nice in that you can just kind of run it and it, whoa.
I like it.
That's a work of art there.
Yeah.
Actually, I'm not sure what I would do with that exactly.
Yeah,
I
they're all.
guess we could look at this relative to some unbiased clusters and see if any of these regions that look distinguished get pulled apart. So we get rid of this so it doesn't recalculate. And then, yeah, the nice thing about Syrah is it runs at the click of a button, and when it's done, you have all this wealth of information. But you don't really get to like fine tune everything.
Yeah.
You might want to, but it all depends on what you're trying to do. Again, small number of cells. Hopefully, this is pretty fast. Yep. Not really. mean, I suppose one thing we did do was drill down the B cells, and then within the B cells, do the difference between these two. Oh wow, that doesn't look right. There we go. So now we're asking what's upregulated in sample 165 versus 166, just within the beat cell.
Yeah, that might be good.
Not a lot. One
What would this look like on cell view?
Well, we would have to do something like color mapping. So it should ideally pick out the swirls of cells in UMAP, for example.
Yeah.
Oh, this one. Well, that didn't quite include any cells. That a little bit more generous. There we go. So, I mean, there's a clinical candidate, right? In
Yeah.
terms of genes that identify 166 that are also involved in VDJ.
How about the other way?
Yeah.
Any candidates here? So there's some. Let's say the VH320 shows a VH. Oh, that's a camp. What about IGHA? Oh, we don't want IGA.
Gamma.
Oh, I gamma HA1. You think that's?
Now let's look at all, we want to. I'm going to duplicate this graph window, maybe a third time as well, just so I can rescale parameters as needed. And then the one, what was that initial gene you just mentioned?
IGH, I think it's IG gamma.
IGHG.
IGH, well,
G1, 2, 3.
Is
Let's
that
try
it?
just with one and see how that works. Doesn't seem to distinguish really anything near the clusters. Make sure it's.
it wasn't that. It was IG. The one you found was not.
Oh, this one.
With the other group, the other one that was high. Oh yeah, there it is. IGHA1, whatever that is. It's A1. Right, I didn't really want A, but because we know it's gamma.
Might be too far. Oh, that's fine. And then make sure I color map by the same gene. I guess you can kind of see, like, I remember this was a separate sample, and it's obviously turned off.
Mm.
The other one that would be interesting to see the total gene set to see how well that identifies things, and it ought to. So, for example, all 37 genes, looking at the sum of information. Look at what a histogram of that looks like, and then maybe adjust this slightly. No. That's not good.
Is there any immunoglobulin genes in that histogram? I guess that's what you looked at before. Yeah,
Right, in these 37,
right. Yeah. Well, not even in histogram, but I guess, yeah. So here's the IG Kappa, IG, so that's all, right.
so these were the genes that were upregulated, it looked like in B cells for sample 165 relative to 166.
Do they look,
It's just the transcriptome. It's not looking at the BCR.
yeah.
Well,
Well,
that's
it's,
The MX1 is there.
yeah.
Fine.
Well, what about, yeah, maybe what Bingen said, can you do for these cells, or whatever, these populations, can you look at B cell receptor in one versus the other? Maybe that would, I forgot this is just a transcriptome, which is something, like IL-4 receptor looks interesting, but like just, can you do the same for these cells up in 165 versus 166 and then B cell receptor sequence or whatever?
The gene for B cell receptor, like BCR,
Yeah, your
Let's say BCR, it's IG, whatever.
yeah, but the VDJ of these cells. No, that's why I keep thinking of cell view to get the cells that are interesting, and then go to gene, and then do immunoglobulin gene for the cells that are interesting. But we're trying to find interesting cells, and you have this swirly diagram. It's hard to pick interesting cells out of there, right?
yeah, I personally don't like this dimensionality reduction is not really meaningless. But there was some distinction between the two samples here.
Yeah,
But I would probably want to review this. I mean, certainly like TSNE should be able to cluster this as well,
Yeah.
but without this sort of like, we used to call this the flying saucer shape. And it's not good.
Yeah.
It's kind of an indication that something went wrong in.
it's more like a spiral galaxy.
Yeah, true. This is the home of the flying saucer people, maybe.
Yeah, right. Right.
Yeah. I mean, these gene sets are, I would say, the most interesting thing that I've seen in this bit of analysis in terms of, we're looking, drill down to B cells,
Yeah.
and then we're looking at genes that are differentially expressed between the two samples.
Yeah.
So these might be, if you're interested in